I guess there is a problem. Yeah. So welcome to the session again. So I thought that my voice was not clear, but yeah, I guess now it is clear, right? Yeah. So this is a basically this is a quiz analysis session. So I have conducted a quiz test for thermodynamics. So yeah, so let's get into this. This quiz was in thermodynamics course part 1. So if you haven't attended the course, take the plus subscription and use my code Padma10. Okay. So if you want to take subscription, then use this code Padma10 so that you'll be getting a 10% discount on the whole amount that whatever you are paying. Okay. Yeah. So yeah. So let us solve the question. So first question is, we have a 1 mole of N2, which is nitrogen at 8 bar and 600 Kelvin is contained in a piston cylinder arrangement. Okay, so we are having a piston cylinder arrangement. So this is a cylinder and this is closed with a piston. Okay, and in this the number of moles are 1 mole and pressure is equal to 8 bar and temperature is equal to 600 Kelvin. Okay, so this is the pressure and temperature initially that we are maintaining in the arrangement. Okay, so now next what happened, it is brought to 1 bar isothermally. So initially the pressure is 8 bar and the temperature is 600 Kelvin, and now the temperature is, okay, we don't know about the temperature. Okay, so they have given that it is an isothermal process. So what do you mean by isothermal? Isothermal means temperature is maintained constant, right? So after the change also temperature T2 will be 600 Kelvin and pressure P2 is equal to 1 bar. So there is an expansion process in which it is brought to 1 bar isothermally against a resisting pressure of 1 bar. What is work done in joules by gas? So basically, they were asking about if it is an isothermal process, what is the work done in the system by the gas? Okay. So for an isothermal process, what is work done? How will you calculate this work done? Okay. So as this is an isothermal process, delta T will be equal to 0, right? So that means change in internal energy is equal to change in enthalpy is equal to C delta T is equal to 0, right? So there will be no change in internal energy and no change in enthalpy, right? So from this what we have, first law of thermodynamics, we can write first law of thermodynamics as du is equal to dq plus dw is first law of thermodynamics, right? So du will be 0 and from this we get dq is equal to minus dw. So they were asking about work done, which means work done can be given as minus pdv, I mean dw is equal to minus pdv, right? So you have to integrate this equation to calculate work done by the system, okay? Yeah, on integrating you will be getting work done is equal to minus of integral P dV. But here P is not constant and V is not constant, right? So express P in terms of T and V. So by using ideal gas equation, what we have, PV is equal to RT, right? So from this T is equal to RT by V. So you can write this equation as minus integral RT by V dV. So from this you will be getting minus of RT ln V2 by V1, right? So work done is nothing but minus RT ln V2 by V1. But if we have information about volume, then you will use this equation. So here we are given only pressures, right? Pressures and temperature is the same. So what you will use? Again, from ideal gas equation, PV is equal to RT. And as this is an isothermal process, RT, the whole RT is constant, right? So from this, P1 by P2 is equal to V2 by V1. So in place of V2 by V1, we take work done is equal to RT ln P2 by P1. Okay. So this is the work done in this process. So by using this question, by using the principle of, I mean, the first law of thermodynamics and the definition of isothermal process, that is T is equal to constant, we will solve this question. Okay. So this is a very simple question and very easy question. So if you know about, if you have the information about isothermal process and what is work done, what do you mean by work, then you'll be able to solve this question. Okay. So R is 8.314 joules per mole Kelvin and the temperature is 600 Kelvin and P2 by P1 is 1 by 8, right? So by using this equation, you can solve this question easily. Okay. So by after solving, you will be getting 10373 joules. Okay. So please do calculations clearly and in a better way. So okay, don't do mistakes in calculations because that is the main thing on which your answer depends, right? So do it properly. And this is how we solve this question. A very simple question and very easy question. Okay. Yeah. So I guess you are clear. Okay. So next question. If you have any doubts while solving the question, please post your comments over here. Then I will be able. Then I will. I will be able to, so that I will be able to answer your questions. Okay. Yeah. So this is a cyclic process, and it consists of three processes. Okay. So this is a cyclic processes. First process, second process, and third process. 1, 2, and 3. Okay. So while going from 1 to 2, from first state to second state, the information about heat and internal energy is given. Okay. So Q1 over here is 10 kilojoules, and from when we are going from Q2 to 3, then it is 30 kilojoules, right? And when it is going from 3 to 1, it is minus 5 kilojoules. So what is negative means? Means what do you mean by negative heat? It means the heat is released by the system to the surroundings, right? So it is also called as an exothermic process, right? Yeah, if heat is rejected to the surroundings, then it is called as uh, exothermic process, and these are endothermic processes. Okay, and we also have information about delta U1 and delta U3. Okay, so what is the work done in the second process and what is the net work output? Okay, so this is a very simple question, but it requires a few steps of calculations. Okay, so basically they require what is the work done in the second process. Okay, and they also require what is the net work output. Okay, so as how just by reading the question, do you got any idea like how we will be able to solve this question? Yeah. So here what we should do is we should take the cyclic process as the basis. Means as this is a cyclic process, the state function for if you consider a state function, both the initial and final states are the same in a cyclic process, right? So because of this, the change of a particular property, which is a state function for the overall process, is zero, right? So here we have internal energy, that is a state function, right? Means it depends only on initial and final states of the system. So because of this, delta U of overall means 1 to 2 plus 2 to 3 plus 3 to 1 is equal to 0, right? So we have delta U1 and delta U3. So from this, delta U from 1 to 2 plus delta U of 2 to 3 plus delta U of 3 to 1 is equal to 0. We need delta U in the second process, right? So from this, delta U of 2 is equal to minus 20 plus 20, which is 0. So here the change in internal energy is 0. Okay. So from first law of thermodynamics, what we get, delta U is equal to Q plus W, right? So that means 0 is equal to, in second process, delta U2 is equal to Q2 plus W2. So in the second process, delta U is 0, and yeah, what is Q? Heat we have as 30 kilojoules. 30 plus W2, right? So from this, W2 is equal to minus 30 kilojoules, right? So we have a change in internal energy in kilojoules and heat also in kilojoules. So because of this, W2 is also in kilojoules, right? So W2 is equal to minus 30 kilojoules. Yeah. So, okay, just give me a minute. Okay. So what we got till now? We got W is equal to minus 30 W2. W2 is equal to minus 30 kilojoules, and U2 is equal to 0 kilojoules, right? So from the before information, so what they were asking? They were asking about what is uh, the net work output. So we should find out in the first process what is work done. Work done is equal to delta U minus Q. So what they have given about delta U, it is 20 kilojoules minus 10, right? So which means 20 minus 10 is equal to 10 kilojoules. So the work done in the first process, W1 is 10 kilojoules, and in the third process, so the third process also, work done will be equal to delta 2, sorry, delta U3 minus Q3. So delta U3 is minus 20 minus of minus 5 kilojoules, because we have given that delta U3 is minus 20 kilojoules and Q3 is equal to minus 5 kilojoules, right? So because of this, it is minus 20 plus 5, which is equal to minus 15 kilojoules, right? Yeah. So what is the overall work done? So work done overall in the process is nothing but W1 plus W2 plus W3, which means work done from state 1 to state 2, so, and from work done for state 2 to state 3, and work done from state 3 to state 1, right? So from this we have W overall is equal to minus 30 plus 10 minus 15. So minus 45 plus 10, which is nothing but work done in the process is minus 35 kilojoules. Okay. So this is the overall work done in the system. So work done in, okay. Uh, yeah, in this question I have given info, options like what is the work done in the second process and net work output. So mark the option which is having a net work output. It is 35 kilojoules. Okay, so this is the correct option. 35 net work output is 35 kilojoules, right? Yeah. Oh, sorry. Okay. So here what we got, work done is minus 35 kilojoules, right? But here the option is 35. So this is not the option, and they have nothing mentioned about like work done by the system or work done on the system. So the option correct answer is none of this. Why I have given this option none of this? because in the answer we got work is equal to minus 35 kilojoules, which means minus 35 kilojoules. This is the net work, right? So but in this option I had only 30 positive work, right? So if it is positive work, then it will be work done on the system, and if it is negative work, it will be work done by the system, right? So so with this change of positive to negative, all the whole work done by the system or on the system changes. So you should select that option which is having none of this. Okay, but if we are having minus 35, then it is a correct answer. Okay, yeah, I guess I'm clear to you. So this is a very simple process. It's just that the only one thing you should know in this process is that for a cyclic process, delta U overall is equal to 0, because this is a state function, right? And it depends only on initial and final states of a process. So in the overall process, the initial state is 1 and the final state is also 1. So because of this, the change in overall change in internal energy will be 0. And yeah, so uh, these are very simple questions and very easy questions. Okay. I hope you are clear, but if you are having any doubts, please post your doubts, I mean, in the comment section. Okay? Yeah. So now we have next question. Parameters A and B and the Van der Waals equation and other cubic equations of state represent. So this is a very simple question. Okay. A represents the molecular attraction and B represents the molecular size. Okay. So what is Van der Waals equation? P plus A by V square into V minus B is equal to RT. Okay. So here B represents the molecular size and A represents the molecular attractions. So basically this A by V square term gives you the pressure, I mean the molecular this pressure because of the I mean in the whole gas. Okay, and B gives you the molecular size. Okay, so I guess you are clear, and if you are having any doubts, please post your doubts over here. Okay, yeah. Okay, next question. So in this question, what we have two processes that are following three different paths. Okay, so let us suppose that this is a graph representing the system, and this is the initial state and this is the final state. Okay, and they are following three different paths. Okay, let us suppose that this is a first path and this is a second path and this is a third path. Okay, 1, 2, and 3. But the initial and final step of the process, I mean in the system are the same. Okay. So let us suppose that this is a representation, and yeah, they have given that initial and final states are the same. So we have kept the initial and final states as same, and then which of the following are correct? Okay. So let us go through the options. Q and W is the same. Delta U is the same. Delta U, Q and W are the same. And delta U, Q are different. Okay. So how will we define this? How delta U or Q or W will be the same or different? How can you say that? We are having different processes, right? And yeah, they are following the different paths. So here we should use the principle of state function and path function. Okay, so based on the definition of the state function and path function, we will be solving this question. Okay, so if it is a state function, as I said before, if it is a state function, what happens? The initial and final states are the only things on which the particular property or state function property depends upon, right? And if it is a path function, it depends on the path through which this final states and initial states are achieved. Okay, so yeah, here, so from these following options, what is, I mean, Q is state function or path function? Q is path function and W is also a path function, and whereas delta U is the state function. Okay, so because of this, for the different as they are following different paths, Q and W will be different and delta U will be the same if like in all the three different paths. Okay, so I guess I'm clear. So from this, what will be the correct answer? Delta U is the same, right? So here we have Q and W is same, that is wrong. Here we have delta U is same, that is correct. And we have delta U, Q and W are the same. So Q and W are not same, they are different in the processes, right? So because of this, option C is wrong. And delta U, Q are different. Here only Q is different for the two processes, but delta U is the same for all the processes, right? So yeah, I guess I'm clear. And if you're having any doubts, please post your doubts in the comment section. Then I will be able to answer your doubts. Okay? Yeah. So next question. So this is about degrees of freedom. So what is the degrees of freedom of triple point of water? So what do you mean by triple point of water? What is triple point of water? Triple point of water means here at this particular point, so at this particular point, we have water in all the three forms. Means in solid state it will be there, in liquid state it will be there, and in gaseous state is also there. Okay. So the point at which water exists in solid, liquid and gaseous state is called triple point of water. And they want to know at what particular point, what is the degrees of freedom of triple point of water. Degrees of freedom means, so if you, what are the other properties that you should mention to define the whole system. Okay. Okay, and you have degrees of freedom as F is equal to 2 minus pi plus n. Okay, so here where pi is equal to number of phases and n is equal to number of species. Okay, so what will be the degrees of freedom for this question? So F is equal to 2 minus, so what are the number of different states that we have, different phases? It is existing in solid state, in liquid phase and gaseous phase also. So pi is equal to 3 plus, what are the different species here? Here we are only calculating for water, right? Means the species that is existing over here is only water. Only this water is existing in different states, right? So because of this, it is 1. 2 minus 3 plus 1 means 3 minus 3, which is equal to 0. So what does that mean? So if you say that triple point of water, then it will be having a particular temperature and particular pressure. So at this particular point only triple point of water will be possible. So there is no need of mentioning any properties like, so if you say that triple point of water, you will be directly able to know what at what temperature and pressure will be having this, right? So because of this, triple point of water is, degrees of freedom of triple point of water is 0. Okay. I Do you have any doubts? Yeah, I guess I'm clear. So next question. The degrees of freedom of a mixture of ice and water are. Okay. So here we have solid state plus liquid state. So the number of phases are 2 phases, right? And it is for water only, right? So number of species is equal to 1, which means F is equal to 2 minus pi plus n, right? Which means 2 minus 2 plus 1, which is equal to 1. So solid ice and water can exist at the same, at the same temperature and pressure, they can exist, but you should mention that a particular temperature or a particular pressure, because based on the pressure, the the temperature at which solid state of ice, solid state of water will be formed changes, right? So because of this, if you mention, if you give any temperature, so at this particular temperature, what is the pressure to be maintained so that we'll be having both ice and water can be uh, defined. Okay. So I guess I'm clear. And yeah, this is the way how you will be solving degrees of freedom. Okay, so if you are having a reaction or if you are having any particular like azeotropic, which is a special condition, right? So if you have that, then you will be using this equation also, minus R minus S. Okay, so you'll be using this equation. If you're having a reaction and any special constraint, then you'll be using this. Okay. Yeah. Next question. Okay. So in this question, we have a man whose weight is 600 newtons. So weight is given as 600 newtons and yeah, he takes time taken is equal to 2 minutes. So he takes 2 minutes for climbing a staircase. So staircase means it is a set of steps, right? So this is called a staircase. And what is the power developed in him if the staircase is made up of 20 stairs, each 0.18 in height? So like this we are having 20 stairs and we are having each stair of height 0.18 meters. So when he climbs the staircase, what is the power developed in him? Okay. So basically this is a uh, application of force and power. By using the basic definition of power and force, we'll be solving this question. Okay. So what is power? Power is nothing but the rate at which the work will be done. Or you can also say that work done per unit time. Right? So this is power. And what is work? So work is also a kind of energy, right? So here we have information about weight, which is nothing but force, right? Force applied on by the man on the uh, stair, right? So work can be given as force acting per unit distance, means F dot dl or F dot L. So from this, we'll be able to know what is work done. So work done is equal to 600 newtons into the height is, the length through which he is passing is 0.18, right? Okay, so 600 into work done is equal to 600 into 0.18. So the each height of the step is 0.18. But how many stairs he is going through? He is going by 20 stairs, right? So the overall height of the staircase will be 20 into 0.18. So work will be 600 into 0.18 into 20, right? So work done you'll be getting as 50 2106, 21600. Yeah, this is the work done Newton meters. So this is the work done on for climbing the staircase, right? Yeah. So I guess you are clear with this. So this is only work done, but we require what is the power generated in the person by while going through the staircase, right? Which means power is equal to work done by time, which is 21600 by time is 2 minutes, right? So here we have units as watts. Watts means joules per second, right? So convert this minutes into seconds. Okay. So from this you will be getting the power generated as 180 watts. Okay. So if you do the calculation with 2, then you will be getting around 10800 watts. but this is not the correct answer, because as we are mentioning watts, then work done should be in terms of joules and time should be in terms of seconds. Okay, so that is why I always tell you to be careful with the dimensions. So read the question, understand it, and check the units. So if you are having watts, the time should be in units, and if you are having absolute temperature, then temperature should be in Kelvin. Okay, so like this, there are few terms in which you have to be more careful. Okay, so yeah, power done is equal to 180 watts. And yeah, next question. A solid is transformed into vapor without going through the liquid phase yet. So we are having a solid and it is transformed to the direct vapor. So what is this conversion of solid to vapor? It is called as sublimation, right? So it will be you will be able to answer this question when you know about triple point of water. Okay, so this is the triple point of water, and this is the point at which triple point of water. So this is solid state, liquid state, and gaseous state. Yeah. So solid is transformed to vapor without going through the liquid phase at, okay, I guess yeah, the correct option is below triple point. So please check the graph of triple point of water. I guess this solid state, liquid, I mean, these states are different. Okay. So yeah, based on this, it will be below the triple point. Okay. Yeah. So next question. First law of thermodynamics. This is a very simple question. It is del dE is equal to dQ plus dW. So this is the law which through which you will be getting the first law of thermodynamics is mathematically stated. Okay. So correct option is option C. And also we had dQ is equal to dE minus dW. So this is also a correct option. So option B is also correct. Okay. Yeah. Next option, next question. Which of the following is an extensive property? So I will be telling you what do you mean by an extensive property. So based upon the definition, you are the one who have to comment the answer. Okay. So extensive property means the property which depends on the I mean which depends on the size of the system. Okay, means if you are changing the size of the system, then the value of the property should be changed. Okay, so based on this, please comment your answer. Yeah, and if you haven't taken and if you want more such type of more like this, more quiz like this and more information about thermodynamics, then do use my code take plus subscription and use my code padma10 so that you will be getting a 10% discount on the whole amount whatever you are paying. Okay, so in this you will be having plus subscribers will be having weekly quiz sessions and doubt clearing sessions also. Okay, so yeah, use this code and get the discount, and yeah, have a happy holiday, um, and yeah, so prepare well for the gate exam because you are left with only 20 days, I guess. So yeah, all the best for your exam.